I think we have still participant being joining in a couple of minutes, but anyways, I'll get started. Uh, Welcome everyone to this session of Learn Python Programming Meetup. This time around, after a long time, we have a guest who gonna be joining us and talking about his own experience and teaching us the things that he has learned along the way with, with his journey in Python programming. Please help me welcome Mr. Ganesh Iyer. He has been associated with the software engineering and specifically Python for the last 5 years, majorly contributing towards the healthcare industry, and currently working as a senior software engineer slash machine learning engineer at MGH Center for Clinical Data Science. And today he will be talking about microservices and REST API and how we can use RESTful microservices to build an app and advantage, disadvantage, and stuff like that. So without late, I will hand it over to Ganesh Iyer. Before that, couple of announcement. First thing, this session is being recorded, and also there is a tutorial or guided workshop or guided Python code at the end of the theoretical presentation. So those who want to follow along, Mr. Ganesh has already said slides and code link in the chat window. So please open up and keep your Jupyter notebook or PyCharm ready to follow along with the presentations. And if you have any questions, you can throw into the chat window, and I will be happy to moderate and take the question, put the question up whenever is possible. We'll try to see if we have time to have the question answer session at the end. You can keep yourself mute. Feel free to keep your video open, and we'll take it from there. So Ganesh, over to you. I'm gonna keep everyone mute, and you can set yourself from here. Thank you.
Awesome. Yeah, let me start by sharing my screen. I think you need to enable screen sharing. It says host disable screen sharing.
Yes. I think it is. Wait.
All right. Yeah.
Right. Okay.
Let me just share. Okay. All right. Is everyone able to see my screen? Nishant, can you confirm? All right. Awesome. Yeah. So I would start off by thanking Nishant for organizing this. Huge shout out to you. I know he's very active in the community and does a lot to promote such events and organizing them. So big thanks. I thank everyone for joining. And I hope everyone's doing safe in these trying times. Out here on the screen, I've shared a link. I've also shared it on the chat window in case anyone wants to follow along to check references of the slides and the code that we'll be talking about. I will add it to the repo that the Meetup group organizers maintain after this presentation. So today I'm going to be talking about RESTful microservices with Python. My name is Ganesh. Nishant has already given an introduction, but I'll just give a 1 minute introduction. I'm a senior software engineer at MGH and BW at Center for Clinical Data Science, working in a microservices architecture team, building microservices for deploying healthcare in the clinic. These are just some links, Twitter, GitHub, etc. This is the link of the repo that we'll be using throughout the presentation. This is a short link for the same. So let's just start by breaking down the title, RESTful microservices with Python. When we talk about RESTful, REST is representational state transfer. So it's an architectural style that was developed early 2000s. Before that was a style that was more prominent for service-oriented architectures was SOAP. And then REST became popular because over HTTP, people started sending lightweight JSON messages. And the whole idea of having a resource fit well with with how softwares are architected in a CRUD manner, as we'll look at in later code. But yeah, so it became really popular, and right now it's probably the most popular way of exposing your functionality to the outside world. So if you look at like Google REST API or any Facebook REST API, you'll be able to find documentation and just all major services expose REST APIs these days. So it's a very useful thing to know about, learn. um, the second part of the title is microservices, right? So before, for people who've been working with code for longer, they would remember like 10, 12 years ago, when you develop an application, it would be a monolith. So all your controllers, all your view, everything would be embedded in one server. And the UI would just make requests to that server and it would serve it. But over time, people started realizing this is not a very scalable approach. There are a lot of disadvantages, right? Like, if imagine if you're just a young intern who joined Google, you don't want to make changes to the mainline to one monolith that would break the whole application. That, fortunately, that's not how Google is designed. They have a lot of microservices. So anyone who joins a new team and they work on a separate service. So for user management, there's a separate service for managing photos and things like that. There are other services. So just a quick overview of what microservices versus monolith architecture looks like. This is probably a better example. So you can see how just to power one page, you have a composition of variety of microservices. Again, this is not from Amazon. This is just a conceptual view, but there are like hundreds of teams working on Amazon just to power this single page. So like the recommendation team works on a bunch of different services to make sure the recommendations that you see for buying a new thing, they work on their own set of services, the navigation and browsing, search, things like that. They all have their own set of services. So what's important is how these services communicated with each other. So traditionally, when we were working in a monolith, you could just do import your code, right? Like when you're writing Python, you just do import math and then you do math.square root to find the square root of a given number. But as you start building microservices, you can't just call from service ABC import my function anymore, because these are services and they need to talk over networks. So there are different types of message formats. The one we will be talking about today is JSON, but other popular formats are XML, protobuf. Protobuf especially is very popular these days. It's it's a Google format that you can that is binary serializable, so it's very efficient, and you can run it over TCP layer instead of the HTTP layer. But for today, we will be talking about JSON, and for our transport layer, we will be talking about HTTP. So at the center, we primarily use a gRPC, which is Google Remote Procedure Call, and protobuf. So all of our services talk to each other over TCP using these protobuf messages. We also have some services that use Kafka. So Kafka is a message queue. You can replace Kafka with any message queue, but the idea is that instead of having a request response, sort of a synchronous communication, you would asynchronously send messages to Kafka, which is a queue, and it'll deal with those messages at its own pace. So those are other things to keep in mind when you think about microservices. It's not just like REST. There's all different kinds of transport layers or message formats possible. But today we will be talking about HTTP and JSON in our RESTful microservices, just because that is the most prominent and popular way these days. Just some background on monoliths versus microservices. We kind of discussed it, but yeah, so understanding the code becomes really hard once you monolith goes to like 10,000, 20,000 lines of code. Just I don't know if anyone of you is familiar, but I've worked in teams where there are certain services that are just so large that even making one change, any new engineer is really scared to do that, and no one wants to touch that service, and people are like, just leave that running without any problem. But with microservices, since they're so small, any people can take ownership. You can divide it into Amazon popularized this two pizza team concept. So if your team size should be something that two pizzas will fulfill it, so like 10, 15 people, and they can own these services. The other thing is tight coupling. So in Monolith, if you have to scale something up, right? So suddenly like one feature of your app or some aspect of your application start getting a lot of traffic. Just say your Facebook and the video streaming aspect of it is getting a lot of traffic. So just scaling that particular aspect, you could just scale the video service. Whereas if you had a monolith, just scaling the whole app would be you're sort of wasting resources because you're also sort of scaling the other functionalities which don't require that much demand right now. Again, making changes, deployments, scalability, embracing risk, and embracing new technology. This is also another cool feature, is that microservices are sort of independent of each other. Like Nishant could be writing a service in Golang, I could be writing a service in Python. Sheikh Mahmood, who's on the call, he could be writing a service in JavaScript. And they can all talk to each other without uh, having to know the internals, because we've already decided on the transport layer protocol, which is going to be HTTP, and our message format is going to be JSON, or even if you're using gRPC or Kafka, and you have these intermediaries and you've decided on the interface, and as long as the service satisfies the interface, you don't really worry about the internal details. So it's really easy to embrace new technologies. So if you want to start using Go or some other new language in your organization, you don't have to rewrite the whole architecture with this new technology. This is just a quick agenda of what we're going to cover. So we already talked about REST plus microservices. Next up, we'll try to get a little more hands-on onto like Git, virtual, and Flask, and the libraries that we'll be using. We'll create a Hello World REST app. We'll create some REST clients, and at the end, we'll start working on a to-do list app, which is going to be our sort of project for this presentation. Okay, yeah, so I think now I'm going to switch my screen and move towards code. Does anyone have any issues or comments? Please feel free to just post it on the chat, and I think Nishant will raise those. So for this, I'm just gonna run a Docker container. If you've never used Docker before, feel free to ignore this step. I'm just gonna do everything in a Docker container, but you can follow along in your local machine, and that is completely fine. I just don't want to add another project in my machine. Yeah, so I'm gonna start by cloning this repository, which is here. Okay, so I have this Python microservices meetup repository. So this is the same link that I sent in the chat window. So what we're gonna do is just do a simple hello world application. So before that, let's make sure we finish all of our steps. So we want to install Git and also install virtual when. So I'm just gonna install virtual env. So for folks who haven't used virtual env, it's just a way of sort of isolating your dependencies, especially when you have a lot of projects running in your machine. You don't want to pollute, like for certain projects, you might want NumPy version 2.4.7. For others, you might want different versions. So to isolate these particular dependencies, you always should work in a virtual environment. So to create a virtual, let's just create a new virtual env. So I have this new virtual env created here. And now I can just activate it using source v and then activate. So I don't know if you noticed, but next to my terminal, I now have vn written, like next to root. That means I'm inside the virtual environment now. So I'm gonna start off by installing all the requirements for this project. Okay, so it installed all these packages. The major packages that we're going to talk about are Flask, which is a Python framework for building RESTful microservices, and requests, which is a HTTP client, probably the most famous HTTP client that Python provides for consuming these REST endpoints. So this is the project website for Flask. It's a micro framework, so very tiny. There's another framework called Django, but for the purposes of this presentation, we're gonna stick with Flask. All right, so I've done cloning the repo and installing the dependencies, and now what I can do is go and check out the server code. Since I'm in a Docker container, I need to install an editor. But if you're on your computer or your Mac, you can just open the file in your text editor. All right. Cool. So yeah, this is a very simple sort of how to build a simple Flask app lesson. So here I have 3 routes. A route is something that we will talk about soon. Actually, I think I should have covered that in the presentation. Okay, yeah, so let me just type it out here then. So when you do www.google.com/search, here it's made up of several. So the HTTPS part is the protocol. So we'll be basically talking about HTTP or HTTPS. And so google.com is the domain, and /search, this is the path. This is what we are interested in right now. So here, when I say app.route/, so this is a decorator that Flask provides that you can decorate your methods around, and any method that's decorated with that particular path, Flask will use that method to respond to that request. So what we can do is create our own route by calling just route to, or just XYZ. Let's just XYZ. And methods, we'll come to what methods are, but for now, let's just do get, and we can do test X. Okay. So we just added another endpoint to this service. The way to run this server is Python -m Flask run. And before that, you need to set your Flask app. So we set it to main.py, which is the name of the file where you define the Flask app. And we just do Flask run. Great. So as soon as I run, it shows me some login messages. The warning is important. It's a development service. Do not use it in production deployment. So this is important. Flask by itself comes with a simple HTTP server, but I don't think it handles concurrency. So if you have more than 1 people accessing it, or they're making blocking calls, your server will just die. So in production, we use something called gunicorn, but for now, you're totally fine running this. And it says it's running a server on 5,000. Now to test this server, we will open another window. So you make sure you keep this server running. And in another window, we're gonna, again, if you're not using Docker, then you don't need to do the Docker stuff. And you can just open another terminal window on your computer and do this. And so now let's go to Hello World client. So there are several ways to consume REST endpoints. The most popular one that comes on most computers is curl. So to test this, I could do curl localhost 5000. And you can see I get a response saying hello world. Now let's try the endpoint we wrote, which is called XYZ. And you see we get the response, we're getting XYZ. This is the response that we had written from our server. So this is probably the most common way people quickly try to test out REST endpoints. Is just using curl, but there are several other ways. The one we're most interested in today is using Python, right? So Python comes with this library called requests. Again, it's a very famous library. And if you just do Python requests, yeah, so HTTP for humans. It also comes with standard URL lib, but I would highly recommend using this library because most of the community seems aligned on this one. Okay, so here we've created 3 consumers. So we get the first base URL, and then we get the my route, and then we get test post. Now let's try to create another simple consumer to get the new endpoint that we just made. So it was XYZ, and response would be request.get URL equals URL. And we're not sending it any data. So and I can just run my client using Python. Oh, I'm not in the virtual end. So make sure you're in the virtual end when you run this. Hello world. Okay, so we got the response XYZ. So yeah, this is just a very quick sort of an overview of how to create and consume these REST endpoints. There's another tool that I like to use to consume REST endpoints. It's called Postman. This is really nice when you have a lot of requests, and if you want to send cookies and authentication information, all that. Curl can become really hard to manage that, but here you can sort of easily organize your project requests. I think I already have stuff for the to-do list app, and we can do something similar for this as well. Cool. So yeah, this just wanted to give you a quick overview of how to do create a few Hello World endpoints. The only thing to that's sort of not that's just kind of different is the decorator. I don't know if people here know about decorators, but there's this great link which gives you additional information about what decorators are. Basically, it's a way to wrap your method around another method. So when you say app.route, the app.route is a decorator, and internally it's implemented like this. And it uses the add URL rule. So if you didn't want to use decorator, you could directly just call the add URL rule as well. But for now, I think we'll just use the decorator. So consuming REST endpoints, we already talked about it, is in the Hello World, you can go to the client, and we have a test client to consume these endpoints. Other ways are Postman, curl. Every language comes with its own HTTP client. It's a pretty standard package. So if you're writing services in Go or JavaScript or any other language, you should be able to talk to this Python service without having to worry about how the Python code is implemented. So yeah, so since we're gonna be using the HTTP protocol extensively, it's a good idea to just talk a little bit about it. I kind of went over this in the text editor, but this is a much prettier picture with colors. So as you can see, the HTTP in red is the protocol, and that's what we're gonna be using. There are other application layer protocols. So for those who've studied the OSI model, they would know that the application layer protocols are FTP, HTTP, and so on. HTTP in turn uses TCP at the transport layer and IP at the network layer. So it's a three-way handshake, but we don't need to get into all those details for now. So your domain is where your service will live. Usually in microservices, it's going to be an IP and a port. There's also this point of like service discovery. So a lot of services usually live in a service registry where they register what their IP address and port is, something like console and so on, because having DNS can only work on on particular machines. But if you want to identify services, you want to use something called DNS SRV record. But yeah, here you have the domain in blue, the path in green, and some query parameters. These are additional messages that you can pass in the HTTP body. So this is an important slide. These are all the methods that HTTP offers. The get, head options, put, delete, and post. The most important ones are get, put, delete, and post. Head is used only for like health checks and stuff. I haven't really used it anywhere else. And options, again, is not used very commonly. But these four are very important, and they map very well to our CRUD uses. So whenever you want to create, CRUD being create, read, update, and delete. So whenever you want to create a resource, you do a post on it. Whenever you want to read a resource, you do a get on the resource. Whenever you want to update a resource, you do an update, and when you want to delete, you delete it. These two columns, safe and idempotent, those are important as well. So idempotent methods are methods that can be called several times without different outcomes. So I can call a get on a website or any REST endpoint without having to worry about some things being changed. But a post, not so much. So a post is not an idempotent, because when you're posting something, you're creating a new resource, and that in itself is not an idempotent operation, right? If you make 100 post requests, you're creating 100 objects. So it's not an idempotent method. The other thing to worry about is whether a method is safe or not. These are also methods that modify resources. So in this case, post and put are not safe, because put can modify and a resource, but it is idempotent, because even if you modify something 100 times with the same payload, so say I had a resource whose name was Apple, and I changed it to banana. I want to change it to banana. Even if I make 100 requests of changing that apple to banana, it's not gonna have any other side effects, right? It's not gonna make it 100 bananas or anything like that. Eventually, it's just gonna be banana. So the safe methods are important because the browser uses them to know whether they can be cached or not. Not just browsers, but across systems. People use that information to figure out whether this method can be cached or not. So if you're making a get request, which is what our browsers make when we're browsing the internet, if you can get large images, you can get large videos, and the browser can cache them. But if you're making a post, which is logging into your bank or depositing money in your account, things like that, the browser can't cache, because You don't want duplicate money being deposited. Deposit is probably fine, but you don't want it uh, getting out of your account multiple times. So that's why safe methods, post and put, are not safe. Uh, this is just a guide of status codes. So when you're writing code, when you do import math, you get exceptions and so on. Python is helpful in that ways. But when you're talking over the network, you lose that ability because your service could be written in Go and so on, or JavaScript or so on. So we use these status codes as reference. So if a service returns a 2xx status code, that means it's good to go, and it was successful in doing whatever operation you asked it to do. 4xx errors, we've all seen them. 404 is the famous not found error. A lot of you might have seen 401s, is when you log into a website and you don't have the right credentials. So 4xx are client-side errors where there's something wrong with how the client made the request. So either the message wasn't formatted properly, or the message didn't exist, or the user wasn't authorized to make that request. 5xx errors are service errors. Again, 500 internal server error. People would probably have seen it once in their lifetime, if not. As a software engineer, you see it multiple times every day. But yeah, so that's something going wrong on the server side. So again, these are how services communicate whether the operation went successfully or was there an exception, or something went wrong with it. So yeah, so I think that was pretty much all I had for the theoretical, so-called theoretical aspect of it. Now I want to jump into getting our hands dirty with some code and build a simple to-do app. You can imagine this to be a part of a larger system where to-do is just one operation and it's just one microservice in a bigger system of things. So yeah, so we need some features, and our product manager here has given us a bunch of features. So the 4 things that our to-do app needs to do is adding items to a list, get all items from the list, update an existing item in the list, and delete an item from the list. So sounds like a simple enough feature list. We'll see how we can implement it using the RESTful way of building software. So yeah, from requirements to REST. So again, as I said, the REST framework works very well with CRUD operations. CRUD meaning create, read, update, delete, which is exactly what these set of requirements are. So sometimes the hard part can be going from requirements to sort of figuring out how you map it to particular resources. And a lot of the times that is the big design challenge, is how do you get from domain concepts, especially in healthcare. Some of them are really obscure. I think I lost my headphone. Hello. Yeah, okay, sorry. I don't know why my headphones died. But yeah, so a lot of the times we spend a lot of time just trying to figure out how to map these requirements to REST endpoints, but here it's easy enough. So we have our resource, which is called to-do, and we have 4 operations: adding an item, which can be mapped to post; getting all items, which can be mapped to a get request; update, which can be mapped to an update. Notice the ID. So when you're updating an existing item, you need to specify an ID for that resource, because there can be several to-do lists. So you need to identify each to-do list, to-do item, and same for delete. So yeah, let's jump into the code example and see how we would go about doing that. So if you go to in the repository, if you go to the to-do app directory, there's two versions. One is V1 and V2. So what I've done is I've left V1 as an exercise for everyone to do on their own time. It just has these boilerplate endpoints. So it has the add to-do, it has the get to-do, and update and delete. So if you guys want to practice after the presentation, sort of work with a real database, work with an in-memory database, do it however you want. You can use the V1 as a template, but for now I'm gonna switch to V2, which is something I implemented yesterday. And I'm just gonna go over a quick overview of how the code is laid out, and we'll try to create one endpoint for for the purpose of this presentation. Uh, so I'm just going to review the code here in GitHub. So again, all of it has some documentation that will help you sort of follow along with it. So yeah, so we before that. So when and again, this is just architectural decision to lay out your code. So we divide our code into like separate layers for the transport layer aspect of it. So as I mentioned, you could have these services running over Kafka, gRPC, or REST. So you don't want to tie your business logic, which is your service layer, closely to your REST or gRPC layer, because those can be swapped around. So that's the approach we try to take. This is a great book called Clean Code, which I would highly recommend. I mean, this approach is used across the industry, but this book gives a great overview on how to sort of structure your projects and write code that's more maintainable. Um, so yeah, so here you can see we create a Flask app and we initialize a repository and a service. So we'll look at the code there. But you can see there are 4 endpoints. To-do method is post, and to-do method get. To-do, and here, this is the new thing that we haven't seen so far, is you can specify some parameters in the URL itself. Here we're providing it the to-do ID, which gets passed to the update to-do method. And this the endpoint, the method HTTP method associated with it is a put. And same for, and delete is for deleting it. Again, we pass the to-do ID and pass it to the service layer. We create a to-do service, which is in service to-do service and a repository. So all your business logic will be in to-do service, and all of your repository, which is the database level stuff, is in the to-do repository. This is a good approach because tomorrow, if I want to change it to a Kafka service, I can just remove this and create a Kafka consumer, and they can still all call the same methods. Let's start by looking at the repository. So I'm using SQLite as a database. SQLite is a in-memory database, in-memory or file system-based database that comes with Python, or it comes with most programming languages. And so we're just creating a table with ID and description and status, so just 3 columns. And we have these methods for getting all to-dos, adding a to-do, updating a to-do, and deleting a to-do. I don't have a lot of time. So what I'll try to do is jump into it and create one endpoint together over this presentation. So imagine like so we have these 4 endpoints, but our product manager comes to us and says they need another endpoint to get a specific to-do item. So the way that would work is, right, so this would be, instead of it getting a list of items, I just want one item. So we can just pass this on. Let me just and this would pass and run the app as it is right now. So to run this, we just do run the app. again, I just want to demo the app first before we make the changes. Okay, so we have this to-do app running, and how do we interact with it? So I've written some curl statements that you can use. Again, it would be a great exercise for you to sort of write these, convert these curl statements into Python requests libraries. So let's start by listing all the items. So you can see it returned an empty array here. Uh, that means there are no items in the to-do list right now. To create a to-do list, I can just copy this curl statement. You can use Postman, curl, Python request. It's up to you. For now, I'm using curl. So here I'm passing this JSON, which is a description and status. So description is this is example, status is active. Let's post this, and you see the service responded with the same message, but it also added this ID field. So I can use this ID field to identify this message. Now let's try to list our curl localhost 5000 / to-do. And you see we get a list of just one item right now. Let's try to add another item. Again, this is why I don't like curl, because it's complicated to do these edits on the fly. This is another example. So I would recommend using Postman if you're if you're doing like complicated JSONs and stuff. Okay, so we have added 2 items in the to-do list, and if we do this, we see 2 items. We can even get a formatted output using Python -m JSON.tool, and this gives us a more formatted output. Let's just quickly do an update. So this one does an update on item 3. We only have 2 items in our list, so we should probably change it to change it to 2. Okay, it says it's a bad request. I think it's the ID that it doesn't. Oh, I know it's wrong. It needs the application headers. So we need to pass these headers as well. Okay, yeah, so I've edited the endpoint. And now you can see it says edited instead of the original message that was. This is another example. So yeah, so that's just a quick overview. Now we were gonna implement another endpoint to get a particular item. So let's continue working on that. So we would just do response equals to service.get to-do, and we pass ID equals to-do ID and return JSONify response. Again, it is important to JSONify at the controller layer. You only deal with your input is JSON, your output is JSON, but at the service layer, you can send dictionaries, Python lists, or whatever like native Python data structures are. But it's important to make sure that at the controller level, your input is always JSON, and your output is also JSON. Now let's add this method to the service layer. So get to do self ID underscore, which would be an int. And we just do a similar, we just call the repository and we listen for any exception. This is another important point, is that you should handle all your service layer exceptions at the so you should always handle all your repository layer exceptions and send a generic service layer message so that the outside world is not aware of your service internals. a lot of times people expose like database information or some sensitive information in their exception messages to the client, but generally when you go to Google or any of the popular websites, they would just have a generic, oh, something went wrong message, which is what you should try to do. Actually, that's not return. We need to do response. So I'm just doing response. And now let's do something similar in the repository. So repository is where you're doing the real database interaction. So we'll do self ID ints. ID is a keyword, so I'm using ID underscore. Query equals. So for those who know SQL, this should be pretty easy. But for those who don't, I'm just gonna try to find select star from items where ID equals ID underscore. And let's make it a F string to respect that. And rows equals none. Let's try to make the connection to SQLite. SQLite 3. Again, if you don't understand SQLite, you can just start by storing, when you do this exercise on your own time, you can just store your lists in an array or a dictionary, start with that. Or if you've used Redis or any other simple database like that, you can also store your list in that. For now, SQLite is a good way to learn it too, because it shows you how to write SQL without having to set up MySQL or having to set any containers and things like that. Or warning, repository error. I'm sorry if I make mistakes because this is, I don't usually write code in Vim. But yeah, I think so. We were able to create this new endpoint to get a particular item. So we added the code to the service layer. We added the code at the repository layer. Now let's hope and pray that it runs. For localhost 5000 to do 1. Okay, so there's some error. We'll handle that. So it's complaining about the ID 1 not being found. Sorry, ID underscore not being found. Oh, it should be get to do. Okay, great. So it did give me a response, but it gave me a response in an array, which is not what we want. So at the service layer, we should fix it and make sure that our outputs are aligned with what our expectation is. So I'm just gonna make it ID and set it to row 0, sorry, response 0, and the description to response 1, and status to response 2. Let's see if that works. Great. Yeah, so now we have the input and output in the format that we expected. So I think that was pretty much what I wanted to share with the To-Do app. I would highly recommend sort of building your own, play around with the V1, which just has the boilerplate, and try to create your own more features, more endpoints, and just play around with it. Try to work with a database, try to work with Redis, or something more complicated if you want to work with MySQL to sort of build this this app forward. I think that was most of what I had. The last thing is deployment, but I don't think I've kind of briefly touched about Docker. I've been doing everything in a Docker container. The way most microservices are packaged is in Docker containers. So you know how right now on your computer, you have applications which are packaged as binaries, and your operating system schedules them. Like, you don't worry about when you open Chrome, where, on which core of your machine it would be running, or what memory address it would be running, and things like that. So similarly for microservices, Docker and or containers have become that packaging unit of choice. And a lot of your data center is now your computer. So people use something like Kubernetes or Nomad, and that runs on top of your data center. And so you can just submit your container to it, and Kubernetes or Nomad will decide where it runs. So you don't really specify, okay, run my container on IP number 10.2.6.8. All that is managed by a service registry or a job scheduler. So I didn't want to dive deep into it, but maybe in a future session we could like talk about Docker. I think it's very important. But a good exercise for you would be to now containerize this application. So being able to run it in a container. I know right now I just did everything in a container, but the idea would be that you just do Docker run to do app, and you'll be able to run everything. So work towards that, and I think that's pretty much all I had. Thank you.
Amazing presentation, Ganesh. Thank you very much, taking your time and teaching us all the industry best practices for building the REST API. We have a couple of questions, and we'll get to that. And before that, I just want to mention what I liked a lot about the presentations. Having someone coming from industry, the biggest value he brings is, I feel like, is like telling people how things work in industry and how to manage the code. Because you can go online, you can find 30 tutorials about how to build an app, but not a lot of people talk about, if you're building an app for an industry, is great, what are the best practices that people follow. And one of those best practices is about like differentiating your app, or breaking down your app into 3 layer, and making sure that all the changes that you make in 3 layer, they are independent. So as you say that we have this main.py, a transport layer, or the layer which only talks about the path that communicate with external environment using the routes. Second layer below that is service layer, which the whole job of service layer is to like take the data from those from your transport layer, and facilitate to do the database operations, and and not actually performing low-level data operations, but having an abstraction where it can call to finally a repository layer or database layer, and everything managed in database layer for talking to database uh, as a proxy. So in future, let's say someone want to change from MySQL or SQLite to, let's say, some other database, you don't need to change all the code all the way up from service, or you just change everything into just single file. So this is something I appreciate a lot, and we also do the similar practices.
Right.
One of the questions that we have from one of our guests, Renuka, was
Hmm.
regarding security. Uh,
Yeah.
can you little bit touch on how we can put security, and what kind of security we can put on endpoints? So when
Right.
you run the app, only selected people or authenticated people have access to app.
Yeah. So this is a great question, and a very problem we deal with on a day-to-day basis. So a very popular way of doing security in microservices is through tokens. So every HTTP request in the header, you would specify a token. A very popular type of token is JWT token, which is called JSON Web Token. So basically, you on which every request you send the payload something like this. It is encoded. It's a two-way signature. So there's a public key and a private key. Only the owners of the service, like if owners of Google, will have access to the private key, but everyone can have access to the public key. And it is signed. So when you're making this token, it is signed by the private key. So you generate a token like this, and it contains some payload data. Like here, it's sub, name, and IST. This is a great website, and people, if they want to check it out, they can check it out later. But uh, so you can create payloads like this, and it will automatically encode it. So the industry practice is to usually have your services, every HTTP request in the header, you send a bearer token or a cookie with this particular token. And most microservices have, in a microservice environment, there's a edge load balancer, which sort of acts as a gatekeeper. There are different ways to do this. In some organizations I've seen, there's a security built into every microservice. So every microservice will make sure that will do this token check. But in certain cases, I've also seen just the edge load balancer doing this check, where it checks it against the public key and sees if the token is valid or not, and only then lets the request go forward. And there is also something called OAuth scopes, this OAuth2 scope. So ideally, your payload data should also contain some scope. So here you can tell. So when you go to Google and say allow this application to read my photos or give me access to my friends and so on, when you log in through Facebook, it gives you a list of things that the app can do. So all that is usually handled through scopes. So you would specify scopes like photo, read, and posts, write, and so on. So you would specify some scopes, and those are used at the application layer to check it. Flask also provides a way to do this. Flask has, if you do Flask bearer token, uh, it provides it out of the box. But most at least in our setting, we've sort of been relying on the edge load balancer to do this check. Where is it? Okay, this one also uses JWT to do it. Yeah, so I would say that that's how it's used across different organizations.
Great. That was excellent answer. I think I also learned a couple of things which I didn't know about security, JWTAI, iOS stuff.
Mhm.
Anyone from the guest list who want to ask question to Ganesh can unmute themselves and ask any question you might have. We still have a couple of minutes. This is first time we are able to complete our session in time. We always run out of like 30 minutes, like after a time. So thank you, Ganesh, for keeping it really tidy with the time.
Thank you. Yeah.
So I don't see anyone having any other questions. One more thing I want to learn about is REST
Yeah.
API. If I want to learn more about best practices with REST API,
Mhm.
do you recommend some kind of resources that I can use? Uh,
Yeah, I think there are like lot of blogs. After this I will send a list of resources that I might not have on top of my head, but there's one blog post that I reference again and again. It's deep in my bookmark list, so I'll have to find it. But generally, the idea is pretty much like you need to make sure that this is in your head. Like I've seen people mix up in a get request, they'll create a resource and things like that, because it can get tricky to, especially if you're too deep into a domain, to differentiate between whether something can be idempotent or not. So making sure that you leveraging this guide and making sure you're not using unsafe or idempotent operations where they shouldn't be used would be the biggest guideline. But there are a lot of books and resources that are available that I can send it out later, which sort of break down how do you go from like domain knowledge and domain ideas to REST-based concepts. A great book is Domain Driven Design. It's not REST specific, but it's just a great book on how you break down domain related problems into software problems. So I think those just having that understanding also helps greatly with mapping it to RESTful services.
okay. And last question that I have for you, Ganesh, is if
Mhm.
someone want to reach out to you from our meetup group, what would be the best way to, let's say, in future, if they have some questions or
Yeah.
some other way they want to connect with you, how would you recommend them to reach out to you?
Yeah, so I have my Twitter and GitHub here. I think you can like tweet at me or direct message me, and I'm very responsive. Even on LinkedIn, I can share my LinkedIn as well. It's I think ganeshayer.net. So yeah, that's linkedin.com/n/ganeshayer.net. That would also be another way to reach out to me. My website's here, and it has all my information as well. It's pretty easy to remember, IR.ai. So my LinkedIn's there, Twitter. Thanks for pointing out that I didn't have my LinkedIn. So I've added my LinkedIn now here. So you can just reach out to me there. Thanks.
Okay, awesome. So to wrap up this event, I want to specify or tell everyone that those who are interested to get the resources for today's event, we will be listing the GitHub repo, the presentation video, as well as the slides on our Meetup GitHub repository. You can find the link on our description page at Learn Python Programming, meetup.com, Learn Python Programming, and just go to detailed about page, and you will see the link where we post our all our meetup videos and all the resources that are being used and presented during the presentations. I will again send one more email with all these links again, so those who are regular with the emails will get them to that. So and again, thank you very much everyone for joining us today, and hopefully this session was very helpful for you. And we also would like to thank Ganesh for uh, sharing his knowledge and letting us know about different things and spending the time with us this afternoon.
Yeah,
Thank
thank
you.
you so much.
Thank
Great.
you.
So Ganesh, yeah, I'll upload the recordings and I'll send it to you, and
Yeah.
the stuff we will
Uh,
communicate with participants.
right. I don't know if Emeka is still on. I sent her the link to. Okay, yeah, she got it. Great.
Okay.
All right. Thank you. Bye
Thank
bye.
you. Bye.
Good night, everyone.